climate has been changing, and our obsession with it only being CO2 seems to be what's driving the debate today. So this panel is going to be looking at possible other reasons that there would be climate change. And I know that Dr. Willie Soon is somebody who is very outspoken in the past about how solar activity could be playing a big role. Think about it, the sun could actually be influencing the temperature. And he will be the first one to speak. Now, he barely needs an introduction. I'm sure everybody in this room pretty much knows who Willie Soon is, but I'll give it just because I'm the host. He's an astrophysicist, geoscientist, formerly with the Harvard Smithsonian Center for Astrophysics. In 2018, he co-founded the Center for Environmental Research and Earth Sciences, CERES. He's been in the news a lot, especially in the past. In our movie Climate Hustle, we featured him as being very much under attack at that time by the New York Times articles and everything. His courage on this issue is really sensational and inspirational, and it always has been to me. So we're really consider this a blessing to have him in our coalition here of people that promote climate realism and sound science. And another little thing about Willie, the guy's funny. I don't know if you've ever seen his videos, but he can carry off humor. I think you were even in California one time. Did you not do a comedy show?
Yeah, comedy improv.
Comedy improv.
Hollywood, yeah, I will. Debating a UCLA professor.
That's right. So little known that, and in fact, you can kind of see in his comedy because I asked him, what are you going to be talking about with response to this topic? He goes, oh, you just tell him Willie Soon's talking. I go, cool, what's at least the title of it? He goes, Wild Goose Chase. So I don't know what that means, but I do know that whatever he's going to be talking about will be very good. Welcome to the stage, Willie Soon.
Thank you, Craig. All right. Are we excited yet? All right, let me get my teleprompter and get started. It's very unusual for me, but since I got only a little time, so I better get straight about my behavior. All right, good afternoon, everyone. Indeed, my name is Willie Soon, and I want to dedicate this talk to the memory of my teacher, colleagues, and friends, Dr. Michael Connolly. Let me start by asking you to imagine that you are standing in this completely dark room. You've been told by the UN IPCC very confidently that somewhere in that room, there is a black cat. You search earnestly, armed with highly sophisticated equipment. After a great deal of effort, you say, I found it. But here's the problem. There was never a black cat in that room. This is a central metaphor of this presentation, and it applies precisely to one of the most consequential numbers in modern climate science, the Earth Energy Imbalance, or EEI for short. EEI is the number that underpins the entire scientific and policy argument that the Earth is accumulating heat at a dangerous and accelerating rate due to human greenhouse gas emission. It is reported by the IPCC AR6 report as roughly 0.7 watt per meter square, a tiny fraction of the roughly 340 watt per meter square of solar energy arriving at the Earth's atmosphere. To understand why this matters, we first need to appreciate the sheer scale of the solar energy system that drives the Earth's climate. The sun is not a polite background light bulb. It is an almost incomprehensibly powerful engine. The sun radiates about 4 times 10 to the 26 watt of total power. For one or two of you that may have fallen asleep in a class when scientific notation was taught, 10 to the power of 26 just means that 1 followed by 26 0. Earth intercepts only about 2 times 10 to the 17 watt of that, so making Earth roughly 2 billion times weaker as a radiating body than the sun itself. Earth's own internal radiogenic heat contributes a mere 2 times 10 to the 13 watt, essentially negligible in comparison. This presentation asks a very deceptively simple question. Do we actually have reliable measurement to support the claimed EEI of 0.7 watt per meter square? The answer, supported by a comprehensive review of the published scientific literature, is a resounding no. To understand why EEI is problematic, we need to go back to its origin. The concept was introduced by NASA climate modeler James Hansen in 1985, paper published in the journal Science. That paper was not primarily about measurements, but it was about climate response time, specifically how long would it take for the Earth temperature to fully respond to increases in atmospheric carbon dioxide. Hansen's model suggests that warming due to CO2 added by humans had not yet been fully realized by 1985 because the ocean absorbed heat slowly, creating a lag. But critically, the energy imbalance that Hansen invoked was not derived from measurement. It was a model output used to argue that humans needed to act now rather than wait for observable warming. This is the historical root of EEI. The abstract of the 1985 paper is revealing. It explicitly states that this unrealized warming calls into question a policy of wait and see regarding the issue of how to deal with increasing atmospheric carbon dioxide. In other words, EEI was not derived from first principle of physics or from measurements. It was constructed from the very beginning as an argument against a cautious evidence-based policy approach. As this presentation bluntly put it, EEI was wholly invented to kill wait-and-see policy response, not as a scientific deduction. That 1985 paper also confessed and admitted that the Earth may at some point undergo a rapid transition to the equilibrium climate for current atmospheric composition. So Hansen indeed also admitted that EEI index may not exist in the real world after all. The crooked road from Hansen 1985 speculation to its current status as an IPCC endorsed measured quantity in 2026 is precisely what this presentation traces, a path, as we shall see, run in multiple loops of circle. The EEI concept reappeared prominently in a 2005 science paper by Hansen and colleagues. That paper calculated using a climate model driven by greenhouse gases and aerosols that the Earth was absorbing approximately 0.85 watt per meter square more energy than it was emitting. The paper then stated that this result was confirmed by precise measurement of increasing ocean heat content over the preceding decade. This is a subtle but critical sleight of hand. The EEI was not measured, it was a model output that was said to be consistent with ocean heat measurements, a circular argument that will recur throughout this talk. Before examining what the satellite and oceans are actually telling us, it is worth pausing on a deeper conceptual question. Does global warming require a genuine net energy imbalance, more energy coming in than leaving, or could surface temperature increases result from a mere redistribution of energy within the climate system without any net planetary imbalance at all? This distinction matters enormously for how we interpret EEI data. According to the pro-IPCC scientists, indeed global warming can only occur because of positive EEI imbalances. But this group of authors was studying climate change from last glacial maximum to the Holocene and the present, appears to be unwilling to admit that there were no human industrial activity to cause positive or negative EEI in the past. With that question in mind, let us look at what the best satellite instrument actually tells us. NASA operates a sophisticated set of satellites called CERES, or the Cloud and the Earth Radiant Energy System, designed specifically to measure the Earth radiation budget, how much solar energy coming in and how much Earth infrared radiation goes out. If EEI is real and measurable, the CERES should be able to detect it. The CERES team owned 2009 paper in the Journal of Climate authored by Norman Loeb and colleagues found that the raw 5-year global mean net flux from the standard CERES instrument was 6.5 watt per meter squared, not 0.85, not 0.7, 6.5. This is very worth highlighting. The raw satellite measurement is roughly 8 times larger than what Hansen's model predicted. The CERES team acknowledged that the major sources of uncertainty were instrument calibration errors of 4.2 watt per meter square and uncertainty in total solar irradiance of 1 watt per meter square. Together, these uncertainties are enormous compared to the claimed EEI signal. You cannot reliably detect a signal that is buried beneath uncertainty several times its own size. What happened next is extraordinary. James Hansen, in a 2011 paper in Atmospheric Chemistry and Physics, acknowledged that 6.5 watt per meter square uncertainty in CERES result. He then wrote that because this result was implausible, The CERES team introduced calibration factor to bring the measured imbalance in line with what their climate model expected, namely 0.85. Read that again carefully. The satellite data shows 6.5. The highly tuned and adjusted model say it should be 0.85. So the scientists insist on adjusting the satellite data to match the model. Then the model was said to be confirmed by satellite data. This is circular reasoning in its purest form. The IPCC's own 6 assessment AR6 report published in 2021 quietly admit this process, as we shall see in the next slide. The IPCC own energy budget diagram show EEI at 0.7 watt per meter square in a neat box in the lower left corner. But the text beside it in AR6 Working Group 1, Chapter 7, page 935, tells a more complicated story. The AR6 text states explicitly that NASA CERES data product were adjusted within the estimated uncertainty to ensure that the net top of atmosphere flux was consistent with the estimate of ocean heat content for the period 2005 to 2015. The satellite measurements were forced to agree with the ocean heat estimate. The ocean heat estimate was then used to validate the satellite measurement. Neither is an independent measurement of EEI. Well, the World Meteorological Organization, WMO, the parent organization of IPCC, is not that far behind in terms of making false claim on the hypothetical EEI index in their latest report on the state of the global climate 2025 put out 2 weeks ago on March 23, 2026. It is rather humorous to us that the WMO heavy promotion of their use of EEI as a key climate indicator for the very first time in 2026 can now be immediately and instantly proven false by this talk and our published paper. But what are the real uncertainty or true error bars of all various proposals of EEI? A comprehensive 2024 paper by Maria Hakuba of NASA JPL and colleagues in Survey in Geophysics confirmed that the calibration and retrieval uncertainties in CERES data remain an order of magnitude larger than the claimed EEI value itself. This is the state of the art, not a historical limitation, but the current situation as of 2024 and 2026. The chart from Hakuba et al. Tells the story clearly. The CERES Terra single scanner data show a mean EEI of 4.4 watt per meter square. The adjusted CERES multi-platform product show 0.76. The two products show nearly the same trend over time, but their absolute values differ by nearly 4 watt per meter square. This is not a minor calibration offset. It is a fundamental inability to determine the absolute level of Earth energy balance. Regional comparison between NASA CERES observation and the European Weather Prediction Center's climate models reveals even larger discrepancy. Look at the bottom graph, where regional differences in incoming shockwave radiation between NASA CERES and the model ranging between plus and minus 8 and 70 watt per meter square in large area. Global averages hide these enormous regional errors that make the hunt for the claimed EEI of James Hansen and IPCC rather like searching for a needle in a haystack, or a very cruel joke if I can be politically incorrect. Let's talk about the ocean. The ocean is the dominant heat reservoir on Earth. Its average depth is approximately 3,700 meters or 12,000 feet or nearly 2.5 miles. Any honest attempt to measure the Earth energy imbalance via ocean heat content must grapple with how much of the ocean we have actually sampled. The answer is sobering. Only 6% of all hydrographic observation in historical database lie below 2,000 meters. Yet, approximately 52% of the entire ocean volume lie below 2,000 meters. The deep ocean, the part where holds most of the Earth's heat capacity, is for all practical purposes unmeasured. The Argo float network, the most advanced ocean monitoring system ever deployed, consists approximately of 4,400 autonomous floats spread across the global ocean as of April 2026. On a global world map, this looks reasonably impressive, dots scattered across every ocean basin, but the appearance of wide coverage of surface ocean conceals a fundamental sampling problem of measuring the three-dimensional volume of water in the ocean. When you filter the Argo deployment map to show only float operating below 2,000 meters, the picture changes dramatically. The dense coverage on the ocean surface evaporates into a handful of isolated dots for deeper ocean, about 230 to be exact. Deep Argo float capable of profiling to 4,000 to 6,000 meters are being developed but remain very few in numbers. The deep ocean is not being monitored. It is being assumed. Of EEI of 0.7 plus or minus 0.2, which rely heavily on the Argo-based ocean heat content measurement. This is indeed the question Jonathan Kohler and our co-author asked in our 2026 paper. What is the true uncertainty of that Argo-derived number? By the way, if you're not satisfied with my talk now, Jonathan is talking at the other room. We all should stop here and just run up there, right? Just kidding. Our paper, entitled IPCC EEI Assessment is based on physically invalid Argo float estimate of global ocean heat content, systematically catalog 5 major categories of uncertainty. Unresolved mesoscale variability contribute plus minus 0.6 to 1.2. Persistent sampling, gap in the deep ocean contribute plus minus 0.35. Altimetry and mass budget uncertainty plus or minus 0.29 to 0.37. Structural discrepancy between the Eulerian and Lagrangian measurement framework contribute plus or minus 0.1 to 0.4. Arbitrary baseline and climatology choices add a further plus or minus 0.1 to 0.3. When compounded at 95% confidence level, the total uncertainty is at a minimum of plus or minus 1 watt per meter square. The claimed signal of 0.7 by IPCC is entirely within that range. It is statistically not different from 0. Therefore, we can safely conclude that the Argo project is not able to rescue IPCC political claim on EEI. Before leaving the EEI discussion, we need to step back even further and ask about the most fundamental input into the Earth energy budget, the sun itself, obviously. But how well do we know how much solar energy is arriving at the top of the Earth's atmosphere? This is the question posed in the next major section of this presentation. The answer is deeply uncomfortable for those who claim precision in EEI measurements. So how does NASA CERES handle the question of total solar irradiance, or TSI for short? The broader problem is illustrated by the available satellite TSI data from 1978 till present. At least 17 different satellite instruments have measured total solar irradiance since the late 1970s. Isn't it obvious that all these satellite data do not agree with each other? Some show TSI values centered around 1365 to 1367, others around 1359 to 1362. The range of values across instruments is several watts per meter square, again far larger than the claimed EEI signal. A comprehensive 2024 analysis by Ronan Connolly, Michael Connolly, and myself and 5 other colleagues constructed 21 distinct TSI composite records from various combinations of these 17 instruments. The composite differ meaningfully in their long-term trend. Some show solar activity declining or staying flat, but others showing increasing trend over recent decades. See the highlighted group F. Grouping the 21 composite by the long-term solar cycle behavior produced 6 distinct families as shown in this slide. The choice of which TSI composite to use in climate model or NASA CERES product directly affect the computed EEI. There is no scientific consensus on which composite is correct. This uncertainty propagates through every EEI estimate that uses NASA CERES data. There is yet another layer of uncertainty that must be confronted. How well can we measure the Earth planetary albedo, the fraction of incoming sunlight that the planet reflects to space without absorbing? Now, let us look at these 2 stunning images of Earth from the DISCOVER or the Deep Space Climate Observatory satellite. The DISCOVER satellite's EPIC camera, which view the Earth as a full disk from the L1 Lagrangian point, 1.5 million kilometers or 930,000 miles from Earth, illustrate the problem of measuring planetary albedo. On your left, on December 13, 2020, Earth measured planetary albedo was 0.35. On August 4, 2020, it was 0.253. This is a difference of nearly 0.1 in albedo, driven primarily by seasonal and meteorological changes in cloud cover. A change of only 0.01 in planetary albedo corresponds to a change in absorbed solar energy of roughly 3.4 watts per meter square. Day-to-day cloud variability alone can therefore produce energy flux change that are several times the entire EEI claim. The full daily albedo record from Discover, covering 2015 to 2021, show enormous variability. The albedo oscillate by about plus or minus 0.02 units or plus or minus 7 watt per meter square around its mean on time scale of days to week with additional seasonal structure. When all the years are stacked together by day of year, a clear seasonal pattern emerged in the Discover data. The albedo peaked near the solstices, June and December, when either the northern or the southern hemisphere is tilted towards the sun and cloud patterns are at their most extreme. Comparing NASA's CERES-derived albedo with the range of IPCC climate model reveals substantial disagreement, particularly in the boreal summer months of June, July, August. The model do not agree with CERES, and CERES does not agree with Discover. None of this discrepancy is small relative to the EEI signal. The most troubling aspect of the discrepancy between NASA CERES and Discover is not in the magnitude of albedo, but in its seasonal timing. CERES data on your left show peak albedo value occurring near the equinoxes, March and September. Discover data on your right shows a peak near the solstices, June and December. These are fundamentally different seasonal patterns. We do not know yet which instrument is correct, and the discrepancy has direct implication for how much solar energy can absorb at different times of the year. This slide perhaps requires no commentary. It is sufficient to note that when climate science's most celebrated satellite team admit that it cannot close its own energy budget without adjusting its data to match the model it's supposed to validate, and when IPCC quietly acknowledges this adjustment in a subordinate clause on page 935 of its Working Group 1 report, the metaphor of confused IPCC climate scientists chasing a phantom signal is not entirely uncharitable. This presentation arrived at a clear conclusion. The Earth Energy Imbalance as currently estimated and reported by IPCC and mainstream climate science is a phantom number. It is not a directly measured physical quantity. It is the residual of a series of model-anchored adjustments applied to satellite and ocean measurements that individually carry uncertainty many times larger than the claimed signal. When the full uncertainty budget is honestly accounted for, as Kohler et al. Do systematically, the total uncertainty in Argo-based EEI estimate is at least plus or minus 1 watt per meter square at 95% confidence level. The signal of 0.7 is entirely within that uncertainty range. It is statistically indistinguishable from zero. I think I'm going to close this, let's wrap up the discussion, right, of the phantom EEI with this quick video. Wow, is this the phantom black cat that IPCC asked us to find in the darkroom? I think the black cat metaphor is apt, not because the Earth energy system is unimportant, but because the confidence with which EEI has been invoked in scientific report and policy document vastly exceed what the actual measurement can support. A more honest scientific community will report EEI as unmeasured and unmeasurable at current instrumental and systematic uncertainties, and would acknowledge that the claimed signal of 0.7 cannot be distinguished from zero with the tools currently available. Until that honest accounting is performed, EEI remains what it has been since James Hansen first invented it in 1985, a policy tool dressed in the language of measurement science. Climatology on the question of Earth energy imbalance is indeed like being in a dark room searching for a black cat that isn't there and shouting, "I found it." Thank you very much for your attention. And of course, this is a warm-up act for a talk that John Clauser will give tomorrow.